We can solve a system in many ways. Elimination, substitution, using our calculators and graphing it, calculating the intersection are all ways that work. But we're going to use second order determinants for this next section. Now, a matrix is a way of organizing numbers. It kind of is like a table. And we have a little exemplary one right here. Now, a determinant is just a characteristic of a matrix. It's used to help solve equations. And sometimes it's written as determinant A like that, or it's used with straight bars, almost like absolute value, or sometimes they just use the letter like that. And using the matrix above, we are going to calculate the determinant by doing AE minus this direction, DB. And that's all you do. So we're going to practice calculating some determinants right here and see how it goes. So the first one we would do 7 times negative 1 is negative 7 minus 4 times 3, which is 12. So the resulting determinant is negative 19. We'll do one more together. Negative 9 times 2 is going to be negative 18. And we're going to subtract 11. So we get negative 29. So why don't you guys pause it a second and try this last one, and in a moment we'll reveal what the answer is and see if you did it right. And the answer to this last one is going to be 0 minus negative 12, which gives us 12. All right, so how does this help us actually solve the system? Well, we're going to use determinants, several different determinants, and D is going to be the denominator determinant. Denominator determinant. All right, and it's needed for solving for both x and y. Now, n sub x, this is going to be the numerator determinant for x, and we need it to solve for x. And lastly, n sub y, as you can imagine, is the numerator determinant for solving for y. So we're going to just practice using this one and see how it works. To set up the determinant for the denominator, you use the x's and the y coefficients, and you just set them up in the order that they're in. For example, 1 and 6, and then 5 and negative 2 for the y's. Now we just calculate our determinant. Negative 2 minus 30, and that gives us negative 32. So our denominator determinant is going to be negative 32. Now, to find the numerator ones, there are a couple of strange things you're going to do. We're going to write the same exact determinant practically. The y's are going to be in the y column. And because we want to solve for x, we're going to replace the x column with the answers. So we're going to replace it with, I'm going to write answers right up here. Negative 36 and 40. We replace them. And now we calculate this determinant. Negative 36 times negative 2 is 72 minus 200. And this is going to end up giving us negative 108. As you can imagine, to solve for the y, it's going to be almost the same thing. We're going to put x where it's supposed to be, 1 and 6, and because we want to solve for y, we replace it with the answers. And we're going to do 1 times 40 is 40, minus 6 times negative 36 is negative 216. And this is going to end up giving us 256. We're not going to worry about what to do with these numbers right now. We're just going to worry about calculating them. Now, using these determinants, D, n sub x, and n sub y, to help solve a system, this is called using Cramer's rule. And all you do is step 1, set up and calculate your determinants, and step 2, solve for x and for y by setting up the following fractions. This will get you the x term, and this will get you the y part of the coordinate. So let's try and do A together. I'm going to set up my D matrix, my denominator matrix, and that's just the x's and the y's, okay? That's all it is. So it's 1 and 7 and -1 and 4. Don't forget to bring the signs along with it. So we're going to go down this column this way. 1 times 4 is 4 minus -7. So we get 11 for that matrix. Now, we're going to try a new one. Let's go and get the numerator matrix for x. So in this one, we put the answer column, and here we put the y's. So I'm going to substitute the x's for the solutions, and I'm going to put my y's back. And let's try it. -11 times 4 is -44 minus a +22, which comes out to be -66. And finally, we're going to sneak up and we're going to do n sub y. And again, we're going to put the x's and we replace the y's with the answer column. So we're going to get 1 and 7 and -11 and -22 here. And that becomes -22 minus -77, which is a +55. How do all these things help us? Well, I'm going to take us just above this so we can kind of see this old thing. What you're going to do now is you're just going to put n sub x over d and reduce. So let's bring it down here. And x is going to equal -66 over 11. And y is going to equal 55 over 11. If you reduce those down, you get -6, 5. And that's your coordinate answer. Why don't you guys try B, C, and D? And I'll put up the answers for you. So hit pause and then check them out after. And now for the answers. You can see that Cramer's rule works especially great if you, let me see if I can, if you have terrible answers, as in letter D. Instead of having to solve by elimination twice, or plugging in something absolutely terrible, by using Cramer's rule, it just gets you those nasty fractions, you simply reduce them, and you're finished. So bring your notes and your questions to class, and I'll see you next time.